Pause the video, try 4 and 5 on your own, and then check your answers. So again, we're going to identify the type of reaction first. Nickel is an element, and lead 2 nitrate is a compound. So this we know is going to be a single replacement that is cationic because nickel is a metal. So now I need to write my symbol. Nickel reacts with lead 2 nitrate. Since lead is a metal, this is an ionic compound, so we need to find the charges. Lead has a charge of 2 given to you in the parentheses. Nitrate is a polyatomic, charge of 1, crisscross, so this becomes Pb parentheses NO3 parentheses 2. So I need to look up nickel and lead. Lead is the ion on the activity series, that the element nickel is above the lead, so this reaction does occur. So nickel's new partner is going to be nitrate. Since the charge of nickel was not given to you, we're going to select 1. Nickel can be a +1 or +2. We're going to state it is just +1 here. So if crisscross, it just becomes NiNO3, and then lead is by itself. Now we need to balance. There are 2 nitrates on the left side, so I need to put a coefficient of 2 in front of nickel nitrate. There's 2 nickels, so I need a 2 in front of nickel. Now we're going to do the states of matter. Nickel is black on the periodic table, so it's a solid. Anything with a nitrate is AQ, so it's aqueous. The nickel is also with a nitrate, so it's going to be aqueous. And lead on the periodic table is black, so it is also a solid. What we just wrote was the molecular equation. Now we're going to write the complete ionic equation, breaking down anything that's aqueous. So the nickel cannot be broken down because it's in a solid state. The lead can be broken down into ions because it's AQ. 1 Pb2 plus AQ and 2 nitrate ions, AQ. This is going to yield 2 nickel AQ because it's aqueous, plus 2 nitrates AQ, and then the lead cannot be broken apart because it's solid. We just wrote the complete ionic equation. Now we're going to simplify. Anything that is the same on both sides, we're going to cancel out. We cannot cancel out the nickel because on the left side it is a solid and it's neutral. On the right side it's a positive NAQ. We cannot cancel out the lead either because on the left side it's an ion and on the right side it's a solid neutral. You cancel out the nitrates because they're exactly the same on each side. So what's left over is 2NiS plus Pb2 plus AQ yields 2Ni plus AQ plus Pb solid. So we have 1 spectator ion. The spectator ion is what we crossed out, which is the nitrate ion. Pause the video, try 6 and 7 on your own, and then check your answers. So we're going to determine the type of reaction. Magnesium carbonate is a compound. Hydrobromic acid is also a compound, so we know this is going to be a double replacement reaction. Magnesium carbonate starts with a metal, so this is an ionic compound. So we need to find the symbol and charge. Charge of magnesium is 2. Carbonate is a polyatomic. CO3 charges 2. They reduce out. It just becomes MgCO3 plus hydrobromic acid is an acid. Begins with an H. Since it has hydro, it's off the periodic table. Bromine 1, so it's HBr. We know this is a double replacement because it's a compound and a compound. And when we have a compound and a compound, the first part of the compound will switch partners. So metals will replace metals, nonmetals will replace nonmetal. For acids, when hydrogen's in the front, it behaves like a metal. So Mg's new partner is going to be Br. So Mg charges 2, Br charges 1, crisscross. So this is Mg Br2. Hydrogen's new partner is going to be carbonate, which is 2, so crisscross, so this is H2CO3. Now we're going to balance, so we need a 2 in front of HBr because there's 2 Brs and 2 hydrogens on the right side. Now we're going to find the states of matters. So we're going to look up carbonate. remember we always look up the anion first, and we find that magnesium carbonate is insoluble, so that's going to be an S. Hydrobromic acid is a strong acid, so that's going to be AQ. Magnesium bromide is going to be AQ. Carbonic acid is AQ. So what we wrote here is our molecular equation. Now we're going to break down everything that is AQ except for weak acid. So magnesium carbonate we cannot break down because it is a solid. Hydrobromic acid will break down because it is a strong acid. H plus AQ and 2Br minus AQ. Magnesium bromide will also break down because it is soluble to Mg2 plus AQ and 2Br minus AQ. Carbonic acid is a weak acid, so it does not break down. However, it does not stay as carbonic acid. Dissociates into CO2 gas and H2O gas or liquid. I'm going to put gas here. So this is our complete ionic. You should memorize that H2CO3 breaks down into CO2 and H2O because you will see this very often. What we just wrote here is our complete ionic equation. Now we're going to break it apart and cancel out everything that is the same. We cannot cancel out magnesium carbonate. We cannot cancel out 2H plus ions, but we could cancel out 2Br minus. So we rewrite it, and this is our net ionic equation. And we have CO2 gas plus H2O gas or liquid depending on the temperature, and our spectator ions are Br minus. Our driving force is the formation of a gas. Sulfur trioxide gas. First one is a nonmetal, means this is a covalent bond. Prefixes become subscript. So sulfur is S, it has none, so that means it's 1. Trioxide, oxygen, there's 3 of them, and it's a gas state. Plus water, and again water I will take either liquid or gas, doesn't matter. Produces sulfuric acid. All acids begin with an H. Since there's no hydro, we know this is polyatomic. Since it ends in an 8, this is sulfate, which is a charge of 2. So crisscross down, so it's H2SO4, and this is AQ. This is a synthesis or a combination reaction. It's also already balanced, is our molecular equation. Now we're going to break down everything that's AQ that is not a weak acid. So SO3 we cannot break down because it's a gas. Water we cannot break down because it's a liquid. Sulfuric acid we can because it is a strong acid. So we're going to have 2H plus AQ plus SO4 2 minus AQ. This is our complete ionic equation. Also our net ionic equation because nothing cancels out. Pause the video, try the next two on your own, and then check your answer. So let's determine the type of reaction. Potassium oxalate is a compound. Calcium chloride is a compound, so we know this is a double replacement. Potassium is a metal, so we know this is an ionic compound, so we need to find the symbol in charge. Potassium is K, charge of 1. Oxalate is C2O4, charge of 2. Crisscross down, so this is K2, C2O4. Calcium chloride. Calcium is also a metal, so this is an ionic compound, so Ca2. Chloride is Cl1, crisscross, so this is CaCl2. Since this is a double replacement, we know that the metals are going to swap places right here. Potassium's new partner is chlorine. They both have a charge of 1, so it's just KCl. Calcium's new partner is oxalate, so C2O42. That reduces out. This becomes CaC2O4. Now we need to find the states of matter. Anything with group 1 except for hydrogen is always AQ. Calcium chloride is also AQ. Calcium chloride is also AQ. Calcium oxalate is insoluble, so that's an S. Now we're going to balance. There are 2 potassiums on the left side, so I'm going to put a 2 in front of KCl. Everything else is balanced. This is the molecular equation. Now we're going to break down everything into ions that is aqueous unless it is a weak acid. So there's 2K plus AQ plus C2O4 2 minus AQ plus Ca2 plus Aq plus 2Cl minus Aq yields 2K plus Aq plus 2Cl minus Aq plus CaC2O4 solid. Remember, solids we cannot break down. This is our complete ionic equation. Now we're going to simplify. Anything that is the same, we're going to cross out. The K pluses and the Cl minuses are exactly the same, so they will cancel out. We're going to recopy, so that's C2O42 minus Aq plus Ca2 plus Aq yields CaC2O4 solid. This is our net ionic equation. Our spectator ions are the two that we crossed out, K plus and Cl minus. And the driving force is the formation of a solid or a precipitate. So for number 9, we're going to determine the type of reaction. We have solid sodium sulfite. It is a compound. And we have hydrochloric acid, which is also another compound. A compound and a compound is a double replacement reaction. We're given solid sodium sulfite. Sodium is a metal, so this is an ionic compound. So we need to find the symbol and charge. Na, charge of 1. Sulfite, SO3, charge of -2. We cannot reduce, so crisscross, so it's Na2SO3. This is a solid because it was given as a solid. Plus, all acids begin with a H1. Hydro tells you it's off the periodic table, Cl minus. So HCl. So Na and H will replace each other. Na's new partner is going to be Cl. So we need to refine the charges. Na1, Cl1. So that's NaCl. So hydrogen will combine with sulfite, which is SO3, 2 crisscross. So this is H2SO3. We know that sodium sulfite is a solid because it was given as a solid. Hydrochloric acid is a strong acid, so that's AQ. Anything with group 1 is soluble except for hydrogen. H2SO3 is a weak acid, but it's still aqueous. So now we need to balance. There's 2 Na, so we need a 2 here. That makes it 2 chlorines. So I need a 2 here. That makes it 2 hydrogen, and everything else is balanced. This is our molecular equation. We break down everything that is AQ except for weak acid. So this is Na2SO3 because it told us it was a solid. This is a strong acid, so 2H plus AQ plus 2Cl minus AQ yields 2Na plus AQ plus 2Cl minus AQ. Sulfuric acid is strong, but sulfurous acid is weak. It does not break down. H2SO3 AQ. So now we cancel everything that's exactly the same on both sides. So we just wrote our complete ionic equation. Now we're going to cancel everything out that is same on both sides. The only thing that is the same is the chlorine ion. Rewrite it, and this is our net ionic equation. We canceled out the chlorine, so we have one spectator ion, which is chlorine ion. However, this problem, the better answer is H2O liquid or gas plus SO2. This right here too is unstable like carbonic acid. Dissociates into H2O and SO2 gas. However, if you write it as H2SO3 aqueous, that is fine. I will not mark it wrong. However, the carbonic acid, you should know it breaks down to CO2 and H2O. The driving force here is actually the formation of a gas. Pause the video, try these 2 problems on your own, and then check your answer. So again, we're going to determine the type of reaction. So this is a compound. The second one is a compound. So we know this is a double replacement. So we have copper 2 chloride. Copper is a metal. So we need to find the charge. Charge is given to you in the parentheses because this is transition. Cl has a charge of 1. So CuCl2. Silver, you need to memorize the charge. Remember, it's a metal. Acetate is C2H3O2, charges 1. So this is AgC2H3O2. Since this is a double replacement, the metals in front are going to replace each other. So copper's new partner is going to be acetate. The charge of copper is still 1. The charge of copper is 2. The acetate is still 1. So crisscross Cu, we need parentheses C2H3O2 parentheses 2 plus Ag's new partner. Ag is 1, Cl is 1 plus AgCl. Next, let's balance. There are 2 acetates on the right side, so I need a 2 in front of silver. That means I need a 2 in front of silver chloride, and the chlorines are also balanced. Now we need to determine the states of matter. So copper 2 chloride is soluble. It is copper 1 that is not soluble. Anything with the acetate is soluble, so that's going to be AQ. So copper acetate is AQ. Silver chloride is insoluble, so that is a solid. We just wrote our molecular equation. Now we're going to break down everything that's AQ, except for a weak acid. So Cu2 plus AQ plus 2Cl minus AQ plus 2Ag plus AQ plus 2C2H3O2 AQ yields Cu2 plus AQ plus 2C2H3O2 minus AQ plus 2AgCl. The silver chloride cannot be dissociated because it's a solid. This is our complete ionic equation. We're going to eliminate things that are the same on both sides. That is the copper and the acetate. So now I'm going to recopy 2Cl AQ plus 2Ag plus AQ yields 2AgCl solid. This is my net ionic, which can reduce a 2 out. So it's just Cl minus AQ plus Ag plus AQ yields AgCl solid. Driving force is a formation of a solid or a precipitate. Number 11, ammonia. This is another one you should memorize for the future. Ammonia is NH3. Ammonium is NH4 plus. That's a polyatomic. Here, ammonium is a compound. With polychloric acid, all acids begin with an H. Charges 1. Perchlorate is ClO4 1, so this is HClO4. This one is actually a synthesis reaction, so I should have given you the product. So it's NH3 plus HClO4 produces ammonium, which has a charge of 1, perchlorate, which is ClO4 1. So we need to balance this. We have 1N. We have 4 H's, 3 from ammonia, 1 from the acid, and then we have the perchlorate. So this is our molecular equation. Ammonia is a weak base, AQ. Again, you need to memorize ammonia for the future. Chloric acid is a strong acid, AQ. Anything with NH4 is soluble, so that's AQ. This is our molecular equation. Since NH3 is a weak base, we cannot break it down. It's like weak acid, so we leave it as is. Perchloric acid is a strong acid, so it breaks down. Ammonium perchlorate is aqueous, so it breaks down. So this is our complete ionic equation. Now we're going to simplify anything that is same on both sides. So that is the perchlorate ion. So if I recopy this, we get something like this. It produces the ammonium ion. So this is our net ionic. And I will not ask for the driving force for this one either. Number 12, this is the equation I asked you to memorize. So carbonic acid is an acid, so it's an H. It's off the polyatomic sheet because there's no hydro, which is CO3, because its ic is 8. So if I rewrite it, it's H2CO3. Carbonic acid is very unstable, so it will always break down to CO2 and water. You need to memorize this equation. Carbonic acid is a weak acid, AQ. carbon dioxide is a gas, you know that. And hydrogen, I would take liquid or gas. This is your molecular equation, your complete ionic equation, as well as your net ionic. Number 13, we're going to determine the types of reaction. Hydrogen is an element. Magnesium chloride is a compound. So we have hydrogen, which is H2. We already know this is a gas because it's read on the periodic table. Magnesium chloride is an ionic compound because magnesium is a metal. Mg charges 2, Cl charges 1, crisscross, MgCl2. If I look at this, I have to look up hydrogen and I have to look up magnesium on my activity series. The element hydrogen is lower than the magnesium, which is the ion, so this one has no reaction. So number 14, we're going to determine the type of reaction. Potassium chloride is a compound. Sodium nitrate is a compound. So we know this is a double replacement reaction. Potassium chloride is an ionic compound because potassium is a metal. We need to find the symbol in charge. So K1Cl1, so that's KCl, plus sodium nitrate, which is also an ionic compound because sodium is a metal. So Na is 1, nitrate NO3 is 1, so crisscross NaNO3. We know it's a double replacement, so the metals are going to replace each other. So K's new partner is going to be NO3. We find the charges. Potassium is 1, nitrate is 1, so that's KNO3. So K's new partner is NO3, which both have charges of 1, so it's KNO3. And Na's new partner is Cl, which is 1, so that's NaCl. So it's already balanced. Now we're going to use the solubility rules. KCl, K is always soluble. Anything in group 1 except for hydrogen is soluble. Same goes with sodium nitrate, potassium nitrate, and sodium chloride. We just wrote the molecular equation. Now we're going to break down everything that is aqueous except for weak acid. So it's going to be K plus AQ, Cl minus AQ, Na plus AQ, NO3 minus AQ, K plus AQ, NO3 minus AQ, plus Na plus AQ, plus Cl minus AQ. We just wrote the complete ionic equation. Now we're going to simplify, cancel out anything that is the same on both sides. The K plus cancels out, the Cl minuses cancel out, Na cancels out, NO3 cancels out. So if you notice, everything cancels out. Since there is nothing left over in the reaction, this is no reaction. When I mix potassium chloride and sodium nitrate, no reactions occur.